Hey guys, welcome back to chemistry. Today we're going to talk about acids and bases neutralizing each other. So from our previous video, we talked about Arrhenius acids and bases. And if you remember, Arrhenius acids are defined as having a proton, which is just an H plus ion. And Arrhenius bases are defined as having hydroxide, which is just an OH minus ion. Today we're going to see how these ions neutralize each other. As the word implies, you're going to have acid mixing with base, and then boom, it will be neutral. So let's take a look as to what that looks like. Okay, so neutralization is a chemical reaction between an acid and a base. And when you have neutralization, you produce salt and water. So here we have a reaction between hydrochloric acid, that is HCl, and sodium hydroxide. Notice how hydrochloric acid has the H in front, like we said for our Arrhenius acids, and sodium hydroxide has the OH in it. So we have our acid and our base, and they are going to react together to form a salt and water. So whenever you have neutralization, you're always going to form a salt and water. So here it makes sense the salt that you get is sodium chloride because your positive sodium ion is going to bond with a negative chloride ion. So your positive guys just kind of like do-si-do, if you will, and switch. So the H switches onto to form water. So the H takes the place of the sodium, and the Na takes the place of the H. So basically, whoever's first, they just kind of switch places. And so you get your NaCl and your H2O. The process of like the actual neutralization, here you have the proton from your acid, and you have the hydroxide from the base, and they are coming together and kind of canceling each other out to form neutral water. Note that you need the same amount of H plus ions as you need OH minus ions in order for it to be a pH of 7, which is actually neutral. If you don't have the same amount of H plus and OH minus ions, you're not going to actually be neutral. So the moles, the amount of these ions, really make a difference. So as we said before, you add an acid and a base together, and you're going to get a salt and some water. Now, you can get a neutral salt and water, or you can actually also make a salt that has an acidic or basic quality to it as well. So, interestingly, neutralization does not necessarily mean that you're going to be a pH of 7. Neutralization just means that you form a salt and water. So in our first example, we have a strong acid and a strong base that react to form a neutral salt and water. In our second example, we have a weak acid and a strong base. So when they react, overall you're going to produce a salt that's actually more basic than neutral, and water. So you are not necessarily at a pH of 7, which is neutral, when you are reaching neutralization. I know that that is kind of not intuitive and weird. We're not going to look at a whole bunch of examples of the second one, but it's just a note that neutralization doesn't necessarily mean that you're neutral. It just means that you formed a salt and water. Okay, so let's just look at some practice problems to see how exactly we could figure out what products we're going to form. So if we have HF, hydrofluoric acid, and LiOH, lithium hydroxide, notice that whenever you have OH in it, it's called hydroxide. When these two react, like I said previously, the first two ions just kind of do-si-do and switch. So because they're both positive, the positive ions are written first usually. They're just going to switch places. So from that, you're going to form LiF, because lithium switched with the H and is now with fluorine. And you're going to form water, H2O, because H switched with the Li, and now you have two H's and an O. So that is how you figure out your products. We can tell that this is the salt because this is an ionic compound. All ionic compounds are considered to be salts. And obviously this is water. So for our next example, we have another acid, HBr. Again, we can tell that this is the acid because of Arrhenius's definition, that it has a positive proton or positive H plus ion in it. And we can tell that this is the Arrhenius base because it has hydroxide, which is OH minus in it. And so again, same as the previous problem, the first two ions are just going to do-si-do and switch places. So you're going to expect to have MgBr and water. Now I realize that there's like these 2's here and here. So I balanced the chemical equation by putting a 2 here and putting a 2 there. Before it just had HBr plus MgOH forms MgBr2 and H2O. So I just balanced it by putting the 2's in front. I know that I had to have 2 hydroxides with magnesium because magnesium has a +2 charge and each hydroxide is -1. So you need 2 of these guys to balance the charge of your Mg. Okay, so let's take a look at the last example. We have HBr and NaOH. This is hydrobromic acid and this is sodium hydroxide. So again, we're just gonna, this is the acid because it has the H in front, and this is the base because it has the OH in back. And again, the front 2 parts are just going to switch places. So our products will be sodium bromide and water. We can tell looking at all of these reactions that they are neutralization reactions because they all produce a salt and they all produce water. At this point, we don't really care whether the salt is acidic, basic, or neutral. We just know it's neutralization because it produces the salt and water. Okay, so in chemistry, we like to do this thing called acid-base titration, and that is where we have this thing called a burette. It's a long glass tube and it has a little knob at the bottom, and the knob just like helps you to slowly add a liquid into another liquid. And the point of titrations is to mix an acid with a base, or you could have the base mixing into the acid. And you do it in this very specific device because it's kind of like a controlled way to add liquid slowly and to know the volume of the liquid that you're adding. You only would ever do titrations, the purpose of them is to try and figure out the concentration of an acid or a base that you don't know. So like, let's say you take some pool water from your pool and you put that in a beaker or an Erlenmeyer flask or something, and you're like, okay, I have all this pool water. I want to know how acidic or basic it is. Let's say you have a hunch that it is on the acidic side. So you're like, okay, I'm going to now add a base to it. And imagine that this solution just like magically turns pink when it's a certain pH. So let's say when it's actually neutral, a pH of 7, it will just suddenly turn pink. So you're adding base, and then all of a sudden it turns pink, and you're like, oh, I must be neutral now. Well, you could figure out the pH of your pool water by going back and seeing how much acid you added, and being like, oh, well, I had to add X amount of acid, so that must mean it took that much acid to neutralize a certain amount of base. So that means that this is the pH of my base. I know that that's a lot. The key idea is really just that you're trying to figure out how acidic or basic something is that you don't know. And you do it using an acid or a base where you do know the concentration of it. So we're going to do some practice problems of titrations. I am actually going to have a separate video where I show you what titration looks like, so I can be a little less vague about it. But this is the titration equation. Let me just get to it. Alright, so here we have, this is on table T. You do not need to memorize it. We're going to use the titration equation to try to figure out a concentration that we don't know. But to define the different parts to it quickly, we have Ma is the molarity of an acid, Va is the volume of an acid, Mb is the molarity of a base, and Vb is the volume of the base. So you have the molarity of the acid times the volume of the acid equals molarity of the base times the volume of the base. So here's a practice problem where you have a certain volume and concentration of a base. Again, we know potassium hydroxide is a base because there is OH at the back of it. And we're trying to figure out what the concentration of our acid is. And so this is nitric acid, and we need to write out the information that we have given to us and then show work for finding the information that we don't have. So for the acid, do we know the concentration of the acid? So we know this is the acid because it has the H in front of it. And we don't know the concentration. That is what we're trying to find out. It says find the molarity. Molarity is the capital M of the acid. Again, I'm expressing this is my acid column because H3O plus is the hydronium ion. So you could just write acid here, but H3O plus is a way of representing acid because this is when you have an acid, you have the hydronium ion in solution. So we don't know the concentration of the acid, that's what we're trying to find, but we do know the volume of the acid is 50 milliliters. And for our base, which again you can represent by hydroxide, just the OH minus, we do know the molarity, it's 1.3 molar. And we do know the volume, it is 42.5 milliliters. So we are now going to use our nifty equation, MAVA equals MBVB. You will sometimes see me write it as M1V1 equals M2V2. It's just saying this is acid, or this is the initial thing, and this is base, and this is the final thing. So let's plug in the information that we have. We don't know the concentration of the acid, but we have the volume, so we just plug in the volume there. We have the concentration of the base, and we have the volume of the base. So all you have to do is solve for concentration of the acid, the molarity of the acid. So this is essentially your X right here. So if you want to get X by itself, you got to move this guy to the other side. The way you're going to do that, because they're being multiplied, is you got to do the opposite sign and divide them. So you're going to divide 50 milliliters from this side and divide 50 milliliters on that side. And you will get your concentration is 1.10 molar acid, HNO3. So you just solved for the concentration or the molarity of your acid using the titration equation. Just a quick note, if you forget that molarity means the same thing as concentration,